Good morning, everybody. All right, so if I remember correctly, in Tuesday's class, we didn't get through everything. So today, my plan is to kind of pick up right where we left off with 6.03, and then any remaining time that we have left over, we'll review a little bit from 6.01 and 6.02 as well. Before we get there, though, just a few announcements of what's coming up here. So, due this week, obviously, we want to make sure we're staying on pace with the calendar. So, we want to get in the 6.02 lesson if you haven't already done so. And then we'll want to turn in that 6.03, and hopefully, you'll be able to do that after today's class. Are there any major questions before we get started here this morning? All right, I'll take the silence as a no. We're good to go. Okay, then remember we were talking about parametric equations. So parametric equations, we have an x equation and a y equation where t is our variable. And we choose this independent variable here, numbers for it, and we substitute that into our x and y to change that or to get some ordered pairs and create our graphs. The other thing we talked about was eliminating the parameter. So basically, that's solving for t in one of your equations and then substituting it into the other. And we looked at that with both kind of linear functions or algebraic functions and then trigonometric functions as well. All right, the last thing we touched upon in class on Tuesday was finding the parametric equations for a line. So kind of starting from the origin out to point A and then from A to B using that head minus tail rule and multiplying by that t variable. All right, so we are going into kind of review mode. We didn't get to really practice those topics very much. So this is where we're going to pick up today is that practicing piece. All right, so the first thing we're going to do is we're going to complete the table and then we're going to choose the correct graph below for the table that we have created. So they do give us our parameters for t. They give us -2, -1, 0, 1, and 2. Let's go ahead this morning and fill in the tables. So you guys have your whiteboard permissions here. Go ahead, pick a couple of the values and fill in the chart. Once we have that chart filled in, we'll use your points to go ahead and identify which graph below is the correct one. Okay, and as I see the table starting to fill in, I will go ahead and put kind of the ordered pairs underneath them just to kind of verify our responses here. There we go. I accidentally did the same thing too. I substituted the 3 in for the y. I'm like, wait a second, that doesn't look right. Yeah, and we get an error here, not available, because we get a restricted domain, right? We can't have 0 in the denominator of a fraction. That throws everything out of the window. So we can't actually create a point when t is 0. So something must be happening at that spot. All right, so taking a look, it does say to omit any points with undefined coordinates. That undefined coordinate would have to be when t equals 0, right? So we do not want to include that in our graph. So looking at the below choices, which graph is going to represent the points that we created from our table up above? Is it graph A, B, C, or D? We can use polling if we want, but yeah, C or, we got differencing of opinion, C or B. It looks like the y-axis is counting up by 2s. B is the correct way to go. Okay, yeah, if I look at overwhelming majority vote now is going to be our B. Yeah, if I look at the difference here, C has 5 points versus B's 4. Yeah, and we know that there's only 4 points to graph. So technically I can get rid of choice C and D because we have to omit a point from the table up above. So there's only 4 values we can really go off of. And it does look like B is going to be that correct choice. We can't really see the values close enough, but they do seem to match up with our table of points up above. Good. Questions with that first example? Okay, it says graph the parametric equations x equals 3 minus t squared and y equals 3t in the specified parameter interval. We are going to go ahead and use our graphing calculator for this because using our technology is going to be key. And I know that some of us were having some issues with that, with the stat plot being on and not working properly. So let's go ahead and start off today. Make sure you're still in parametric mode in the graphing calculator area there, right? So in that mode button, make sure you're in parametric. And then when you go to your y equals, we'll want to clear out the 2 equations that are there and then type in the 2 new ones that they're looking for. If you want, you can go ahead and change your viewing window. So when you have your equations typed in, before you hit graph, you can go to the window. And it looks like our T min needs to be at 0, which I have in there already for mine. And then the T max needs to be changed to 10. So we must have been dealing with a trigonometric function the last time because that was a 2 pi in there originally. So we'll change that T max to a 10. And then we can go ahead and hit our graph. When we do that, which graph do you see on your calculator? A, B, C, or D? So Tommy, Isaias, Rebecca, all see graph C. Rachel sees graph C. Ta-da! I also see graph C. Yay! So it looks like we all have our calculator issues figured out because we did get the correct graph that time around. So that's good news because I know we struggle with that a little bit in Tuesday's class. Did anybody not get C with further graph on their calculator? Remember, there is that online graphing calculator if you don't have a handheld one that you can work your parametric equations on. I believe it's in the online lesson. I threw it in there. So if you don't have a handheld graphing calculator, use that one that's in the online lesson area. All right, let's go ahead. It looks like we're going to eliminate the parameter here. I have x equals t minus 5 and y equals 5t. So in which equation here, the x or the y, do you want to solve for t in? So we're going to work on eliminating the parameter. So which one do you want to solve for t? The x, okay. So working in this equation right here, how would I get t by itself? Or what will t equal when it is by itself, I should say? X plus 5 or 5 plus x, yeah, however you want to write that. Addition is commutative, so if you flip them around, that's okay. All right, then now that we have t, we use substitution into the y equation. Y equals 5 times x plus 5 now. So distributing that is going to be what, 5x plus 25. And which graph does that match up down below? And we don't need a graphing calculator for this one. You should be able to identify which graph that's going to be out of your choices. Yeah, the only one that makes sense is graph B, right? Because you have a y-intercept of 25. The only one that has a possible y-intercept of 25 is graph B, and then we have a positive slope of 5. So B is also looks like it has a positive slope there, and it's kind of steep, so it very well could be a 5 for that slope. So definitely I would go with choice B as well. If you want to try to verify that, you can. You can graph these two or plug in these two equations into your calculator and see what the graph output is, but it should match up to choice B. All right, let's work with those trigonometric functions then. How do we eliminate the parameter if we're given trigonometric functions? Does anybody remember the process we do here? It's a little bit different than what we do with our linear ones. Yeah, we're going to go ahead and use the Pythagorean, not necessarily the Pythagorean theorem, but Pythagorean identity, right? So that sine squared plus cosine squared equals 1. Yeah, I know that's what you meant. All right, so if I'm going to use that Pythagorean identity for our trig functions there, what exactly am I going to do with the two equations they start us off with? So x equals 8 times cosine t and y equals 8 times sine t. How do we eliminate the parameter for this? We don't really want to keep the cosine and the sine in it. We do want to eliminate the t part of it. So refresh your memory just a tad bit from Tuesday. If you're dealing with the sine and cosine functions, that's essentially what you want to isolate in each of your equations. So the process is a little bit more involved when we're dealing with our trig functions, in that we do need to isolate the trig portion in each equation. So we'll get that cosine of t kind of by itself there. So we have to divide both sides by 8. And then the same thing with the y, divide by 8 so you can get that sine of t isolated. And now you can go ahead and square these and then substitute them into your Pythagorean identity. So that's going to look like an 8 squared over 64 plus a y squared over 64 equals 1. And then we can go ahead and multiply through by a 64. And what is the graph of this going to look like? So we have now eliminated the parameter. We no longer have t's in there at all. It's all x and y. But what's the graph going to look like? It's a circle, right? So most of the time when we eliminate the parameter here, especially if you're just dividing by the same number, your graph's going to be a circle. This is going to be a circle with a radius of 8, right? So looking over here at my choices, it looks like A is going to be the correct graph for that circle. All right, any questions with eliminating the parameter if we're dealing with trig functions? No, that's a great question. Will you be getting trig functions beside cosine and sine? I don't believe so. No. All right, how about this one? Oh, hold on. It says use an algebraic method to eliminate the parameter and identify the graph of the parametric curve. This one's going to be very similar to the last one we just did, right? So you can probably already see the circle that's going to be forming here. So we know that there's going to be an x squared plus y squared. Any guesses what the radius squared is going to be, or what the radius might be? If we can figure out the radius, then yeah, or the radius squared, we can go ahead and substitute that in. So it looks like the radius squared is going to be our 9, right? So this is going to be a circle with radius 3, because that seems to be the pattern that it follows, whatever value we are dividing by. That seems to be the radius of our circle. So if we need to write the equation, remember it's x squared plus y squared equals r squared. So we do want to use a 9 there for the radius squared. Now, we do want to pay attention to the parameters that they put on t though. So this is not going to be a full circle. It looks like it's only going to be a half of a circle. So when we go to graph this, we do want to pay attention to what values we're looking at. For t, it's starting at pi over 2 and ending at 3 pi over 2. So really, our graph is going to look like a circle, half a circle, that goes through quadrant 2 and quadrant 3. So when we're identifying what the graph is going to be, just pay close attention to those parameters or the interval for t. Any question with this one? We get pretty used to the format after we do so many of them, because it can't really switch up too much, right? So okay, how about this one? So this is mimicking creating a set of parametric equations for the line that passes through the 2 points there. So remember the format that we did to create parametric equations for a line that passes through 2 points? We essentially started by changing the first point to a vector, right? So I'm going to follow that same rule here. And then the second vector we can create is using the head minus tail rule. So what is going to be the second vector we get here? So assuming that this is the terminal side and this is the initial point. So terminal minus initial there. Yeah, 5 minus negative 2. So head minus tail rule, 5 minus negative 2. And 7 minus 4, Isaiah says that's going to be a 7, 3. So I'm just going to go ahead, write that vector 7, 3. I'm going to go ahead and distribute the t through the second vector. And now we can create two parametric equations for this. what will the x equation equal according to our setup here? Yeah, negative 2 plus 7t. We grab those from the x position of the vectors, right? Negative 2 plus 7t. What about the y equation? 4 plus 3t. Good. And I'm going to look above, and it looks like the third choice is going to be the correct answer there. Yay! All right, good. We got lots of practice then there that we weren't able to wrap up in Tuesday's class, but are there any other questions lingering out there about 6.03 with our parametric equations? All right, do you remember which ones? I have my book here. We can take a look at them. Okay. All right, so question 13, use an algebraic method to eliminate the parameter and identify the graph of the parametric curve. Use a grapher to support your answer. So they give us x equals a 2t minus 3 and a y equals 9 minus 4t, and they're giving us the interval of 3 is less than or equal to t is less than or equal to 5, it looks like. This is the one that you're looking at, right? All right, so we want to go ahead and create an equation, so that means we have to isolate t in one of the equations they gave us, x or y. I generally try to start with the x one if I can. So to isolate the t there, what needs to be done? So if we want to isolate t in this equation, what should we do? Start by adding 3, good, to both sides, and then what's the last step? Divide by 2, yeah. Now just make sure that everything is divided by 2 there. Okay, I'm going to go ahead and substitute that into the second equation. Now to simplify this, I notice I have a negative 4 divided by 2 here. So technically what we can do to clean this up a little bit is simplify that to a negative 2 on the outside. So 4 divided by 2 is 2, and then distribute the negative 2 through the parentheses. So 9 minus a 2x, and then minus a 6. So combining like terms, we'll have the negative 2x. 9 minus 6 is a positive 3. So I believe that's what we should get when we eliminate the parameter. Sure. Sure, yeah. It does say to graph it as well, but it says you can do that with your graphing calculator. So if you keep it in parametric mode, I would probably just plug these in for the x and y equations, fix your window so that it's only graphing from 3 to 5 for our t, and then you can see that graph there. Good. Any other questions from the book, like the practice problems from the book? Mhm. Yep. Okay. So I believe that your viewing window will change. Well, originally, if you're in the parametric mode, your viewing window will not change. It should be 3 to 5. But when you graph in the rectangular mode, after we eliminate the parameter, these will change slightly. What you need to do is substitute these values into the equation here to find the new interval. So we'll start with substituting 3 in for t into this x value here. So you'll get x equals 2 times 3 minus 3. So that'll be a 6 minus 3, which is 3. And then to find, so that's the low end value for x, because x is essentially that independent variable now, right? Just like t was. So to find the high end, we have to substitute the 5 in as well. So 2 times 5 is 10. 10 minus 3 is the 7. So if you are graphing in strictly your rectangular coordinates there, you will only be interested in the values from 3 to 7 inclusive for the x's. So that's where they got the 3 and the 7 from, by substituting that into just the x equation. Yeah, we haven't really addressed that before, so that was a good one to bring up. Any other questions from the book at all? I have a few other examples we can take a look at regarding 6.01 and 6.02 before we wrap up here today completely. So we'll take a stroll down memory lane for a little bit here before I let you go today. All right, so the first thing here, it says, are the directed line segments A, B, and C, D equivalent? Justify your answer. So first we're looking for a yes or no, they are equivalent, and then how do we know? First of all, what does it mean to be equivalent? You guys remember back from 6.01, how can we tell if two vectors are equivalent? Yeah, same vector. So if two things are equivalent, same vector, same magnitude, right? So essentially what we're going to do is we're going to put these into component form, right? So let's start with A, B. Remember, you're doing head minus tail, or tail minus head rule there. Head minus tail? HMT, right? Yeah, head minus tail rule. What do we get for the vector of A, B in component form? We actually should get the 6, 0. Yeah, because if we're doing head minus tail, we're going to do 0. Nope, it's okay. That's why we review too, right? 0 minus negative 6, and then negative 3 minus negative 3. Those do turn into plus signs here. Two negatives turn into a plus, so that's a 6, 0. Knowing that, what is the component form for vector CD? Yay, 6, 0. We got it that time, right? 10 minus 4 is 6. Negative 2 minus negative 2 is 0. Yay, it matches up. All right, so are they equivalent? So yes or no, are the two directed line segments equivalent? Yeah, all right, so we can get rid of choice A and we can get rid of choice C because yes, they are equivalent. Now, what's the correct reasoning behind it? Yeah, we're looking at those vector representations, so 6, 0. Good. All right, the first thing we're going to do for the next one is find the component form and then the magnitude of the vector PQ. So first thing is the component form of vector PQ. What do we get for that component form? Aw, nice little heart. 3, 1. Yeah, so our hearts are our 3s, right? Gotta love the emoticons there. Now let's talk about the magnitude. It's been a while since we've seen magnitude. How do I find the magnitude of a vector? So magnitude is the length. How do we calculate that? Square the x and y, add them, and put them under a square root sign. Beautiful. I believe that they like to use a and b, but I like the x and y. So in this case, it would be a 9 because 3 squared is 9, plus 1 because 1 squared is 1. So our magnitude is the square root of 10. All right, let's go ahead. It seems like forever ago again, right? When we were doing our scalar multiples and our addition here with our vectors. But let's find 8u plus 10v. So if you'd like to write on the board and complete this one, or if you want to do it on a piece of paper and just put the answer on the board, go ahead and do that. But when you have an answer, make sure you let me know what you get. And hopefully we'll all match each other. So we're trying to find 8u plus 10v. We got one answer out there. I'll throw that up on the board, a 102 and a 160. We'll wait for a couple other people to confirm or deny, I guess, technically, if they have a different answer. Oh, I see some typing. Isaias and Rachel both confirm that, and I'm going to confirm it as well. Good. All right, so we do get that. If, in fact, I would probably do 8, multiply each of these by 8, multiply each of these by 10, and then add 72 plus 30 and 80 plus 80. Good. Ooh, unit vectors, fun. All right, find a unit vector in the direction of the given vector, -5, -10. All right, so when we're trying to find a unit vector, we need to calculate something first. What do we have to calculate? The magnitude. Yep, we need the magnitude of the vector because essentially we will be multiplying 1 over the magnitude through the vector we're given. So what is the magnitude of this vector? Yeah, it looks to be 100 square root of 125. Does that one break down at all? I think it does. Can we break down 125? Any perfect squares that go into that? I'm thinking 25 might go into that. All right, so when we simplify that radical of a square root of 125, I can break that down into 25 times 5. Square root of 25 is 5, and I got the square root of 5 kind of left over there. All right, to find the unit vector, don't forget we're going to multiply 1 over 5 times the square root of 5 through our vector v. All right, so this is going to result in a -5 over 5 square root 5 and a -10 over 5 square root 5. Let's go ahead and simplify that a bit. It looks like those are going to cancel and that can be simplified. So technically we don't generally like to leave the square roots in the denominators, but we're going to go ahead and do just that for these unit vectors. So we are going to leave those radicals there. So that should be the unit vector. If you were to go through and find the magnitude of that unit vector, what would it equal? So if you were to find the magnitude of that vector, it should equal 1, right? Because unit means 1. So if we did it correctly, that should be a 1 for the magnitude. And I can see that it will be because you'll get a 1 over 5 plus a 4 over 5. So that is going to result in a 5 over 5, and the square root of 1 is 1. So it'll work out okay. Questions with the unit vectors at all? Okay, I see Zai is typing, so when that pops up, I'll make sure to answer your question or statement there. Aw, how cute. All right, the next thing, and probably one of the last things we'll look at here today is finding the component form of a vector if we are given the direction and the magnitude. So a lot of the times in 6.01, we had to refer to that formula of resolving the vector. You guys remember that formula? So it was like, I believe it was the magnitude of the vector times cosine of the direction of the vector, and then magnitude of the vector times sine of the direction of the vector. So hopefully that is bringing back some memories, right? We used that quite a bit when it came to finding direction, if that was missing, and then maybe even the magnitude at times. Maybe not the magnitude, but definitely finding direction if needed. So in this case, what is going to be the magnitude looking at that diagram off to the right-hand side? What's the magnitude of the vector? Yeah, remember the magnitude is the length of the vector. So in this case, it's the 21. What is the direction angle of the vector? That's your 57. Now notice it's 57 degrees, right? So if you wanted to leave it exact, you could, but it does say approximate answers as well. So if we want to go ahead, make sure we are in degree mode with the calculator. I think we can leave it in parametric mode. It should still be okay if we're working in parametric as well. Let's test it out though and see. Yeah, it'll still come out okay even if we leave it in parametric versus function mode, but we do want to make sure we're working in degrees. So what is going to be approximately this vector as a decimal? 11.44. Oh no, Isaiah's calculator is acting up again. And 17.61. Let's just make sure that you changed it to degree. Did you get it to degree versus radians? Because it looks like it could possibly be in radians still. Okay, so we'll check that first. And fingers crossed that that was what was wrong with it. And here are my responses. It says it's in degree mode, and you tried punching it in just like this then. 21 times cosine of 57. Did you do the 21 times that? I'm trying to figure out what may have been missed. Okay, phew. I'm glad it was just a typo. Because I'm like, oh no, I'm running out of options of what might have went wrong. Good, I'm glad we found that then. Did everybody else get these responses? Hopefully. If not, I can try to troubleshoot with you guys and find the errors there as well. Okay, good. The story problems. Let's see, we don't have too much time left here. I don't know if I have any story problems in here today. I do not. Generally with the story problem ones, we are trying to figure out what the magnitude and what the direction are. And if you can find the magnitude and the direction, then you're going to be using that resolving the vector formula to help you with the problem. So when I take a look here, like on page 465, don't forget that speed is also your magnitude, right? So speed is velocity, which is your magnitude in your problem. So if I were to take a look at like question 41, maybe, it says an airplane is flying on a bearing of 335 degrees at 530 miles per hour. Find the component form of the velocity of the airplane. So I believe what we would have to do there, and let me just check real quick. I'm not quite sure how they're getting their answers for that one. But if we look at that one, I think what you would have to do is you take your 530 and then you would do your, oopsie, sorry, that's on the inside. So that's your magnitude times cosine of your direction. And then the same thing with your sine. Now they got a negative and I ended up getting a positive. So I'll have to take a look at that one. But generally we're just following the same format where you do magnitude times cosine of your direction and magnitude times sine of your direction. That's generally the format that we follow with those story problems. Oh, and I see what you guys mean with the answers being mixed up, right? Because I got a 480 for this one and a negative 223.98. And I think this is what Tommy and Isaias and I think Rebecca were talking about at the start of class the one day. They said some of the answers in the book were mixed up. This is one of those. So in the answer key in the book, they have those reversed. Yeah, so I'm not quite sure why they have them reversed. That's a little strange, but we are doing them correctly. We should get them in that order. So maybe that's what was happening and why it seemed a little bit confusing was because the answer key is mixed up. It's almost backwards, so to speak, in that component form. So that's a little strange. Exactly, right? Exactly why updates happen. Yeah, set up an office hours appointment for the quiz one. We can take a look at that one together for sure. I do have office hour appointments tomorrow. They're booked for today, but I do have lots open for tomorrow still. So feel free to drop in and we can take a look at one from the quiz and work through that one together for sure. Yeah. All right, any other questions out there before I let you go here today?